In section 5, we're going to talk a little bit more about isosceles and equilateral triangles. So as a refresher, an isosceles triangle is a triangle with at least two sides congruent. And there are a couple special properties about an isosceles triangle. So the angle formed by the congruent sides is called the vertex angle. And then the two angles formed by the base and one of the congruent sides are called the base angles. And just a reminder, the base angles are always opposite the congruent sides. So the isosceles triangle theorem states if two sides of a triangle are congruent, then the angles opposite those sides are congruent as well. So as I previously stated, but it is a theorem. So for example, because side AB is congruent to side CB, then angle A is congruent to angle C. So let's go ahead and use this theorem in our first example. So we know DE is congruent to CD and BC is congruent to AC, and the measure of angle CDE is 120. What is the measure of angle BAC? Let's go ahead and label what we know. So we have DE and CD congruent, and then we have BC and AC congruent. And then we know our angle CDE is 120 degrees. And then angle BAC is in our second triangle. So we want to find that angle. So first we want to find the two missing angles in our triangle CDE, since we're given one of the angles. So we know that angles DCE and DEC have to be congruent because they are the angles opposite the congruent sides. So they both have a measure of x, which I can use the triangle sum theorem to solve for. Since we know 120 plus x is going to equal 180. So we get 120 plus 2x equals 180. Subtract 120. We get 2x equals 60. Divide by 2, and x equals 30. So the missing angles in triangle CDE are 30 degrees. We also know that angle BCA and DCE are vertical angles. And vertical angles are congruent, which means angle BCA is going to be 30 degrees as well. So now we can use the fact that triangle BCA is also an isosceles triangle, and its base angles are congruent to help us solve for angle angle BAC. So we can both label those angles as y. So we know 30 plus y has to equal 180. So 30 plus 2y equals 180. Subtract 30 from both sides. We get 2y equals 150. Divide both sides by 2, and we get y equals 75, which means the measure of angle BAC is 75 degrees. We also have the theorem that if two angles of a triangle are congruent, then the sides opposite those angles are congruent as well. So it's kind of like the reverse of the isosceles triangle theorem. So we have angle D congruent to angle F. Then we know those opposite sides, DE and FE, are congruent, which would then make the triangle isosceles as well. So in our second example, we want to name all of the congruent angles. Well, two angles are already labeled congruent for us. So angle PML is congruent to angle PLM. Then if we look at our second triangle MLN, ML and MN are congruent, so we know that its opposite angles are congruent as well. So we know angle MLN is congruent to angle MNL. We also want to name all of the congruent segments. Well, we're given two segments congruent already. We know that ML is congruent to MN. And then in triangle MPL, by the theorem we just talked about, since the angles PML and PLM are congruent, the sides opposite are congruent as well. So then we also know that PM is congruent to PL. And those are the only angles and segments we know for sure to be congruent. So we also have a corollary, which just comes from a theorem. And this corollary states a triangle is equilateral if and only if it is equiangular. So what this means is that if all the sides of my triangle are the same length, all of the angles have to be the same measure as well, and vice versa. If all of the angles are the same measure, all of the sides have to be congruent as well. And this comes from those two theorems we just talked about, because if I know that two sides are congruent, so its opposite angles are congruent, and I pick another two sides, the opposite angles have to be congruent, so that ends up being all three angles and all three sides being congruent. Another corollary is that each angle of an equilateral triangle measures 60 degrees. Since all three angles have to be the same, there's only one possible angle measure for those, so that when I add all three angles together, you get 180 degrees, and that only works if each angle measures 60 degrees. So if you have an equiangular triangle, it also is equilateral, which means that every angle automatically measures 60 degrees. So using this, we know that triangle EFG is equilateral and EH bisects angle E. So we want to find the measure of angle 1 and angle 2, then we want to find X. So with EFG being equilateral, we know all of our sides are congruent. So EF, EG, and then FG are all congruent. It also tells me that angles F, G, and E all measure 60 degrees. And since EH bisects that angle, it means it splits it in half. So since we know the measure of angle 1 equals the measure of angle 2, and we know the measure of angle E is 60 degrees, splitting that in half tells me that the measure of angle 1 and the measure of angle 2 are both 30 degrees. Okay. So now we can use the fact that angle F is 60 degrees and angle 1 is 30 degrees to help us solve for X, since the point H creates a triangle FEH, which also has to have a sum of 180 degrees. So we know 60 plus 30 plus 15x has to equal 180 degrees. 60 plus 30 is going to give us 90, plus 15x equals 180. Subtract 90, we get that 15x equals 90. And then we're going to divide by 15. And we get that x equals 4. Sorry, 6. 90 divided by 15 is 6. So we have solved for angles 1 and 2, and we found the value of x. So as you're completing the assignment over isosceles and equilateral triangles, if you have any questions, please ask.